Hello all, I am Archana, Assistant Professor in E&TC Department, ASSMS IOT. Here we are going to discuss over here, that is pulse modulation techniques. So firstly we are going to see what is meant by the modulation process. Modulation is the process of frequency translation in which any one of the parameter like amplitude, frequency or phase of high frequency carrier signal is varied in accordance with instantaneous value of low frequency modulating signal. Modulation is either analog or digital. Many signals in modern communication systems are digital. Additionally, analog signals are transmitted digitally. So, digitizing a signal results in reduced distortions and improvement in the signal to noise ratios. A digital signal is superior to analog signal because it is more robust to noise and can easily be recovered, corrected and amplified. For this reason, the tendency today is to change an analog signal to digital data. The process of transmitting signal in the form of pulses discontinuous signals by using special technique. So that technique is nothing but the pulse modulation. So basically there are two types of pulse modulation, analog pulse modulation and digital pulse modulation. So first type of analog pulse modulation is PAM, pulse amplitude modulation, pulse width modulation and pulse position modulation. And in digital pulse modulation there are basically first type pulse code modulation and second one is the delta modulation. For this modulation, pulse modulation, the process which is used, that is called as the sampling. So first we understand what is meant by the sampling and then we are going to see the pulse analog modulation techniques. Sampling is the process of transmitting signals in the form of pulses by using special technique. The signals is sampled at a regular interval of time and which is proportional to the amplitude of signal at that instant. This technique is called as the sampling, and sampling technique is a common for all pulse modulation techniques. In the sampling, the analog signal is sampled after every Ts second and Ts is referred as a sampling interval for the sampling, and Fs is nothing but 1 by Ts and which is called as the sampling rate or sampling frequency. Basically there are three methods of sampling: ideal, natural and flat top sampling. So in this diagram also you can able to see these three types of the methods, three methods of sampling: ideal sampling, natural and flat top. So what is meant by the sampling rate? Nyquist showed that it is possible to reconstruct a band limited signal from periodic samples as long as the sampling rate is at least twice the frequency of the highest frequency or components of the signal. So Fs sampling frequency should be greater than equal to twice of the frequency of the modulating signal. If the sampling rate are too low, the results or that generates aliasing or fold over error. So here you can able to see the sampling process. This is the continuous time signal and that gets sampled at the regular time interval, and that time interval is the Ts. Then here we are going to see the first type of the pulse analog modulation, that is the natural PAM. So in this type of the natural PAM, pulse amplitude modulation, so this is the circuit diagram for generation of the natural PAM. So in this circuit diagram, first diagram you can see over here, this is the XT signal which is applied, that is nothing but continuous time signal, and over here one switch is used, that is the chopper switch, and chopper switch here MOSFET that is acts as a switch, and gate terminal of the MOSFET that is apply the train of pulses CT. So this MOSFET acting as a switch. So when the pulse amplitude is higher, this switch will get turned on, and when pulse amplitude is lowest or 0, the switch get turned off. So in this way, when you apply this continuous signal xt to this circuit, when switch get turned on, the output of this circuit you are getting this signal. You can able to see in this waveform when switch get turned on and when switch get turned off. So when switch get turned on, output of this circuit will be 0. Again, for the next cycle of the pulses, the switch get turned on and output you are getting the continuous time signal for that particular time duration too. After the same time duration, time interval Ts, again switch get turned on and output you are getting like this. In this way, the signals which you are getting at the output is called as the natural PAM, and amplitude of that natural PAM signal is same as the amplitude of the modulating signal, and that follows the modulating signal amplitude for that particular time duration only. So this type of the modulating signal, this type of the pulse amplitude, this type of the pulse amplitude modulated signal is called as the natural PAM. Also in this diagram, you can able to see the baseband signal xt gets sampled by the regular interval of time, and the output you are getting the pulse amplitude modulated signal, and this is the natural pulse amplitude modulating signal. Then we go for next type, that is the flat top sampling. So name itself indicates the flat top. So in this flat top sampling, if you can see over here, the pulses, top of these pulses, that is the flat. So this sample and hold circuit is used for the generation of the flat top sampling. So these are the two types of the pulse amplitude modulated signal, natural sampling and flat top sampling. Here also you can able to see the waveform of the flat top sampling. Thank you.